All right, so today what we're going to do is we're going to talk about piecewise functions. So piecewise functions, that really means you are taking a piece of a function and it is a combination of one or more functions. So I literally am, my notes are kind of like just showing you examples. So the first thing we're going to look at is if I want you to evaluate a piecewise function. So if I want you to evaluate number 1, and I have 2x plus 1 if x is greater or less than or equal to 2, and then x squared minus 4 if x is greater than 4. What I want to do is I want to pick the one that fits here. So of my numbers, which one is less than or equal to 2? Well, that's 1. So the first one I would have 2 times 1 plus 1. So h of 1 equals 3. So the reason I wrote h of 1 is because you are going to have two different functions. So you have to clarify which one you're plugging it into. And then number 4, or x equals 4, 4 is greater than 2. So then that means I plug, so this is the first one, I plug that in the second one. So I'm saying 4 squared minus 4. So that's 16 minus 4, which h of 4 equals 12. So let's look at the second one. I have x has to be less than or equal to -1. Do I have anything here less than -1? So some of you are like, oh. All right, so let's look at a number line. If I have 0 here and then -1 here, does 1 or 4 fit here? No, it doesn't. So there isn't anything that fits in this one. So then for g of 1, it does fit in the second one. So then I would have 5 times 1, because 1 is greater than -1, which g of 1 then would equal 5. I would do 4. Is 4 greater than -1? Yes. So then I plug it in. G of 4 equals 5 times 4. So g of 4 equals 20. Okay, so then the next part is this exact same thing, I just made it look bigger. It says evaluate each piecewise function for x is equal to -1. So this one looks really crazy, right? Because it just has numbers there, it has no x. So then what you are doing on that one is you are just picking where it fits. So if I have x equals -1, is -1 less than -3? No. Is -1 between here? Yes. So f of -1 equals 15. Is -1 greater than 6? Nope. All right. So sorry, that's kind of hard to read, both of those. So this is f of -1. Then I have 3. So is 3 less than -3? No. Is 3 between here? Yes. So then f of 3 equals 15. Is 3 greater than 6? No. So those are my two answers. All right, so I'm going to let you do the next one. All right, so that should be your answers. Now, what I want to do is we are going to graph them. Okay, so graphing sometimes is confusing. So what I want you to think about is that you're really just graphing just like you would before. All right, and then I'm going to explain something. So if I just graph this line right here, I'm going to go up 1, 2, 3. and then I'm going to go up 1 to the right 4. 1, 2, 3, 4. Up 1 to the right 4. 1, 2, 3, 4. And I'm going to draw a line. Okay, so what this line says though is the stipulations say that it only wants the part of the line that is less than 0. So here is 0. So it only wants the graph that is less than 0, which is this part. Because here's my x's, right? Here's where my x's are getting smaller. So then I don't need that part. That's the only part I would keep. Okay, so let's look at another one. Okay, so up 3. Oh, and this would be an open dot because this is less than, not equal to. So we'll go up to 3, and then we're going to go down 1, 2, to the right 1. Down 1, 2, to the right 1. So here is my line. And it says it wants everything where the x's are greater than 0. Well, this is where x's are bigger than 0. So then that means I need this part of the graph, okay, this part of the graph, and it fills in that dot because it's equal to. So now my graph looks like that. Okay. Let's look at another one. All right, so x minus 3. So I go down to 1, 2, 3. And then look, I want everything less than 0. So I'm actually going to go down 1 to the right 1. This is where it is. So I just want everything on this side. This should be an open dot though, because this is less than. Okay. Now it's 2, so y equals 2. So remember, f of x and y are the same thing. So then if y equals 2, I go up 1, 2, I would actually want this line. But it tells me that I only want the part of the line from 0 to 1, 2, 3, 4 with an open dot because that is less than. So then the rest of that we would erase. Look at another one. So now down 6, 1, 2, 3, 4, 5, 6. I'm going up 1, 2, 3 to the right 1, 2. Now this is saying it wants everything greater than 4, so I'm going to get to 4. I'm at 2 right now, so up 1, 2, 3 to the right 1, 2. Okay, so this is where I'm supposed to be. So I'm going to erase these dots. Now from here it says that I want where all the x's are greater than. So remember my points were, let's see, 1, 2, 3, 4, 5, 6. My points were here. So that means I would want all the x's greater. Where are all the x's greater? This way. So then my graph is going like that. Okay. All right. Well, what if I switched it on you and I wanted you, okay, on this I shouldn't say I switched. Let's evaluate. So I have f of negative 3. So I'm going to negative 3. 1, 2, 3. Where I have to go to the nearest graph, where am I? 1, 2, 3, 4, 5. I'm at 5. So f of negative 3 equals 5. F of 2. 1, 2. So I go down to the graph. 1, 2, 3, 4, 5, 6, 7. So this is 7. I go to negative 5. 1, 2, 3, 4, 5. Down. That's 5. Okay, so you're going to that graph. Now, I think I maybe put one, let me see if I have, oh yeah, I do up there. Okay. Okay, so let's do this one. So f of negative 2. 1, 2. So if I'm at 2, I'm going to go 1, 2, 3, 4. That's where I'm at. So 4. 0. 1, 2. 6. 1, 2, 3, 4, 5, 6. Go up to my graph. 1, 2, 3 and a half. Okay, see how that works? All right, I think I have a few more down here. Just that last one? Yep, one more. Okay, so this is all one function. So f of negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going down 1, 2, 3, 4, 5. I'm at 5. I go to negative 3. 1, 2, 3. I have to go up because I don't have any graph down here. So 1, 2, 3. So I'm at 3. I go to 4. 1, 2, 3, 4. Oh, shoot. Look what happens. I have a closed dot and an open dot. So because this one's closed, that is my answer. So that is 3. So a closed dot takes preference over an open dot if they're together. Okay? All right, that's it. If you have questions, come in a seminar or after school.